Welcome all of you. So previously we studied how to design a standalone solar PV system. We discussed about different components of standalone PV system such as batteries, inverters, charge controller and solar PV module, and how do we assemble them, how do we design their configuration based on the given load. So today is the last lecture of this component of solar energy, where we will be focusing mainly on policies, subsidies and some of the bigger companies and solar PV plants in India. So we will start with National Solar Mission, followed by solar PV cost and subsidies in India, the top solar PV companies and plants, the solar PV environmental impact and the case studies. So National Solar Mission, Indian government has got several missions for several important areas. One of them is National Solar Mission, which was launched in 2010. It is also known as Jawaharlal Nehru National Solar Mission when it was launched, and it is the bedrock of India's energy transition. This is because the contribution of solar in India's installed capacity has been very significant. So far as renewable energy installation is concerned, solar is one of the most leading ones. So installed capacity at present in India, it has crossed 150.2 gigawatt of solar capacity as of March 2026, and total installed capacity of India at present is 533 gigawatt. So almost 28% of this installed capacity is coming from solar, and total close to 50% is coming from renewable sources. Globally, India is ranking third in solar power capacity, and when this mission was launched, it implemented its target in 3 phases. So phase 1 was from 2010 to 13, where target was just 1.1 gigawatt and it was achieved. 13 to 17, phase 2 target was 10 gigawatt, which was also achieved. Phase 3, which overlapped with the time of COVID period, the target was 20 gigawatt, but it was later revised to 100 gigawatt and it was achieved in 2025. And as per the Vision 2030, the India expects to increase this 150 gigawatt to almost 300 gigawatt, and that will bring the solar component to almost 60% of the total renewable energy capacity. And under this mission, there were several schemes. Some of the key schemes were PM Surya Ghar Muft Bijli Yojana. This scheme focuses mainly on the rooftop solar plants for India, and target was setting up rooftop plants for at least 10 million households and providing 300 units of electricity free every month. PM Kusum Yojana, this was aimed at solarizing the agricultural sector of India, mainly through solar pumps or grid connected solar pumps on barren lands. Third, Solar Park Scheme. These facilities actually provided the plug and play type of infrastructure for ultra mega solar projects, for example Bhadla or Pavagada projects of solar plants. They fall under Solar Park Scheme. The fourth one is Green Energy Corridor. This is like a dedicated transmission line or an infrastructure project which is used to evacuate renewable energy. For example, in 2026, recently almost 600 crore rupees budget was passed to complete 6,000 kilometers of intrastate lines for electricity transmission. So these were some of the key schemes implemented under National Solar Mission, and India is on a great path so far as solar energy is concerned, and it has been achieving its targets before the deadline. Second, residential solar PV cost and subsidies in India. Since PM Muft Bijli Yojana, that was the most implemented in India for millions of households, the residential solar PV, there were many subsidies implemented by the government. And these subsidies are dependent on the capacity of the rooftop solar. So, if it is 1 kilowatt or 2 kilowatt, per kilowatt central financial assistance, it is central subsidy is around 30,000. So, if the cost of the system is 65 to 70 or 1 lakh 20, when we remove the subsidy per kilowatt, the net cost to house owner comes in the range of 35 to 45,000. Okay, and for 2 kilowatt, it is just double of that. But after 3 kilowatt, after 2 kilowatt, right from 3 kilowatt or higher, there is a cap on the subsidy, and it rises by only 18,000 compared to 2 kilowatt. Okay, so the net cost to homeowner becomes higher for higher capacity systems. Okay, and based on this PM Surya Ghar Muft Bijli Yojana, the guidelines given by this scheme and the current market averages, these schemes provide subsidy only to those rooftop or residential solar PV which are connected to the grid, because when it is connected to grid, it becomes easier to monitor and check how much power has been generated and how much power has been exported to the grid. So, because of metering and proper measurement in grid connected systems, subsidies are limited only to grid connected systems. When we talk about overall PV subsidies in India, if you summarize what we saw in the table previously, the central financial assistance, it is capped at 78,000 for systems higher than 3 kilowatt. But this is a central level subsidy. There may be some state level subsidies implemented in addition to the CFA by certain states like Delhi and UP. They provide additional state subsidy of 30,000 extra, and this will reduce the net cost to house owner further. For claiming central subsidy, there are certain norms. One is you must use domestic or satisfy the domestic content requirement. So, the solar modules that we are purchasing, it should be from empaneled vendor. There is a list of more than 500 vendors which are empaneled by the government, and we should produce or procure solar modules from them, and it must be ensured that most of the majority of the content of solar modules should be made in India. So, that satisfies the DCR requirement. For PM Surya Ghar Muft Bijli Yojana, they do not provide subsidy for standalone or off-grid PV systems. Like I said earlier, they provide only to the metered systems or the grid connected systems. And there may be certain exceptions for certain programs which may provide off-grid subsidies, and that will be limited only for agriculture or for remote regions which are not at all connected to the grid. But for the regions which are not remote and which are connected to the grid, for them subsidies won't be applicable. So, if you have to find off-grid subsidies, there are certain sectors. One is PM Kusum's component B. So, when we talk about PM Kusum, it's Pradhan Mantri Kisan Urja Suraksha Evam Utthan Mahabhiyan scheme. So, it's related to farmers, farming and agriculture. It was launched in 2019 by MNRE, and it had 3 components. Component 1, it was for decentralized grid connected solar power plants, the small ones less than 2 megawatt. Component B, standalone solar agricultural pumps, and component C, solarization of existing grid connected pumps. So, out of these 3 components, the component B, which is for standalone solar water pumps, subsidy amount are provided. So, they are not connected to grid, they are standalone solar water pumps, but still they are eligible for subsidy amount of 60 to 80%, and for that mainly the individual farmers in off-grid or remote areas are eligible. Second, hilly and special category states. So, some of the regions in these states may be off-grid, they are not connected to the grid. So, for such areas, if they have off-grid solar lights or home systems, up to 90% of subsidy can be claimed, mainly in the states of Uttarakhand, Himachal, Northeast and some islands. Then there is MNRE's off-grid program, which is mainly for solar street lights and study lamps. For them, central assistance is provided, and it is implemented usually through state level renewable energy development agencies like UREDA applies it in Uttarakhand. So, this was all about the subsidies, like we saw the overall PV subsidies and the schemes under National Solar Mission, and finally the off-grid subsidies, which are some of the exceptions. Now, solar PV panel cost components in India. So, there are different components or different processes where we can bifurcate the cost for a typical solar PV panel, and most of the highest portion of the cost comes from the hardware, or the, like, it can be panels, inverters, batteries. It's around 52%. So, more than 50% of the cost goes in the hardware. It's the most dominant part, and the prices are very competitive, but they hold a larger share of total cost. Second is supply chain and logistics. This is mainly the transportation and warehousing, like the storage and processing costs which are involved, that is 15%. Labor cost is around 9%. It's lower compared to the developed nations because of the relatively low labor rates in India. Overheads and operations would be 8%, permitting and interconnection, customer acquisition, and financing and contingency. These are average numbers if we distribute the solar PV panel component cost wise in India. Now, if we typically just focus on the material or the bill of materials for solar panel, the range of cost changes from 55% for solar cells. Solar cells are the most expensive part of the solar panel. And now assembling or the other components of the panel, like say backsheet, junction box, encapsulants, frame, glass, and all the assembling process or the manufacturing process, they all lie between 4 to 12%, where manufacturing is only 9%. So, the highest share of the cost in the panel comes from solar cells, and in India, most of the solar cells or the components required for manufacturing solar cells like silicon or semiconductors are mostly imported from China. So, if you look at the top solar PV companies in India at present, these are I think top 10 list, and you can see most of them are headquartered in the states of Maharashtra or Gujarat, where we have like enough sunlight. So, Tata Solar Power, Adani, Wari, Vikram, Renew Group. So, all these companies are headquartered in different cities, and they have got different manufacturing module or cell capacity. As you can see, Tata Solar Power, most of the companies, they have module capacity or the module manufacturing capacity. Very few companies have got cell capacity. So, as you can see, for Wari Energies, module capacity or the module manufacturing capacity is 13 gigawatt, but cell capacity is only 5 gigawatt, and that's what the truth is. In India, cell capacity is very low and module manufacturing capacity is very large. Module manufacturing capacity, it is the ability to assemble solar cells into final modules or panels, and this process is typically less capital intensive or less expensive, and it has grown rapidly to more than 100 gigawatt in India at present. But when it comes to cell capacity, it is the capacity to produce solar cells that actually go inside the modules, and this cell production requires significantly higher production cost, and they significantly rely on the imports even for the cells or for the materials that would be required to manufacture those cells. So, it is significantly lower at present, the cell capacity in India. So, you can see all these companies which have got on an average 5 to 10 gigawatt module manufacturing capacity, most of them are having plans to expand to double of their capacity, which shows there has been a huge growth in manufacturing solar PV panels within the country. So far as largest solar PV plants in India are concerned, one of the current plant which is of highest capacity is around 9,400 capacity, that is Khavda Renewable Energy Park in Gujarat, and it is operating, but it has a plans of expanding by 3 times more of its capacity to almost 30,000 megawatt. Then Bhadla Solar Park, it was one of the biggest when it was constructed. It's in Rajasthan, 2.2 gigawatt. It is fully operational and it was completed in 4 phases. We will study this park as a case study in detail in the next slides. Then there are other solar parks in Rajasthan, in Karnataka and Andhra Pradesh, ranging from 1 to 2 gigawatt. There are some small size plants less than 1000 megawatt in Andhra Pradesh and Madhya Pradesh, in Kunta and Rewa, and they were, most of these plants, if you see, they were completed in different phases, because there are many reasons, like one is land area constraint, second would be the capital investment or the cost, and third would be the availability of the material or panels all at once. Also, when it is connected to the grid, it goes in the step wise manner or in the phase wise manner. Now, we have looked at the National Solar Mission PV policy, subsidies, and solar PV component cost wise, cell capacity and module capacity. Since solar PV is a leading renewable energy resource or a technology, does it have any environmental impact or not? Because we call it as a renewable, so obviously it is expected to have least or very low environmental impact. So let's have a look. When we talk about solar PV plant or panel, it starts from raw material extraction, manufacturing, then there is installation, operation, and after its life is end, it can be either recycled or reused. And when we compare it on key environmental metrics with fossil fuels, let's see the CO2 emissions for solar PV. It's low, like 35 grams per unit of power, and these are almost 95% lower compared to coal based power generation in kilowatt hour. Then water usage, it's minimal. It is required mainly for washing the panels, and very least amount of water is going into regular operations. Then 90% lower compared to fossil fuels. Toxic waste, it is high at the end of life, which is typically 25 years. And in case of fossil fuels, it is relatively low and it requires specialized recycling. Actually, the toxic waste from solar PV requires specialized recycling in comparison to fossil fuels. Land intensity is high for large plants, and footprint, that is the area requirement per megawatt, is significantly higher for solar PV compared to the fossil fuel. Now, if we bifurcate this solar PV panel manufacturing process in upstream operational and downstream process for a typical PV based plant and compare it against coal. So, these are different life cycle stages. What we can observe is highest emission for solar PV happens in the upstream process, and then amount of emissions go on reducing. Whereas for coal based power plant, highest amount of emissions, almost 100%, happens during operational process when we are mining, preparing coal, transporting and burning it in a power plant, and very less emissions happen in upstream and downstream processes. So, when we compare it, it is 35 to 40 grams CO2 equivalent per kilowatt hour, and for coal it is almost 1 kg or 1000 grams CO2 equivalent per kilowatt hour. And these are the upstream processes, which includes extraction of raw materials, infrastructure, plant construction. Same here. And in operation, we will have power generation, system plant operation and maintenance. Here, it will be mainly combustion of coal or power plant operation and maintenance. In downstream, it includes decommissioning and disposal. Same here. Here it will be coal mine land rehabilitation. Let's look at one case study of Bhadla Solar Park. It is located in Rajasthan. The place is called as Bhadla. It's one of the place in Thar Desert. So it has good solar radiation intensity. Capacity is 2200 megawatt. It is fully operational and it was constructed in 4 phases. In first phase, 65 megawatt was plant. Second, 680, then 1000, and then finally 500. And the type of panels used in this PV park is monocrystalline as well as polycrystalline and bifacial models. The total cost of the project, excluding the land cost, was 10,000 to 12,000 crore. The capacity factor of this is around 19 to 25%, and it was varied by phase and tracker technology. The employment generated while this plant was constructed, it was almost to 10,000, and for operation and maintenance, it is employing 1500 to 2000 people. And the project was funded by Asian Development Bank, World Bank, SBI, and IREDA. So, if you look at the different challenges and what were the impacts and mitigation strategy for Bhadla Solar Park, let's look at them. So, one big challenge was reduction of yield by 30% because of soiling and dust. Because the PV plant is located in the desert with the winds and air blowing over the panels, lot of dust used to get settled on the panels, which will reduce the efficiency of the panel. So, for that, robotic dry cleaning, which is actually the waterless automated brush, was proposed. We could not, or the people there could not propose water based cleaning as it was in Thar desert and there is scarcity of water. So, water scarcity was second challenge. Manual wet cleaning was impossible. So, waterless technology, it reduced the dependence on groundwater also. Extreme heat, high temperatures in Rajasthan, because high temperatures would reduce the maximum power. It will reduce the efficiency. And for that, the mitigation strategy was selection of modules which can work fine at higher temperatures, which will have low thermal coefficients. For example, monocrystalline PERC cells. Then grid instability. If the output is intermittent, as obvious, solar PV plants output would be intermittent depending on the intensity of radiation, and that will change and that will add stress on the grid. So, for that, advanced forecasting is proposed as a solution. So, AI driven weather and load management was implemented. Sand ingress, because of abrasive sand, the lots of sensitive electronics were damaged. So, for that, filtered housing was used. And transmission losses because of remote location. So, the one of the schemes of National Solar Mission, which is Green Energy Corridor, which ensures that long distance dedicated high voltage evacuation lines for renewable energy, that will reduce the effect of sand, like transmission loss. Then thermal stress because of diurnal temperatures, like the frequent changing temperatures. So, for that, flexible mounting, which is made of galvanized steel, which can expand based on higher temperature without any ruptures or fractures. So, those are the mitigation strategies for respective challenges. And for this plant, which was completed in 4 phases, there were different developers for each phase, and different companies or different generation developers or IPPs were also involved in different phases. For example, for 65, it was Rajasthan state government for first 2 phases, and the subsequent phases was done by a joint venture with IL and FS, that is Saurya Urja, and Adani Renewable Energy Park got into it towards the last phase. For this Bhadla Solar Park, because it was constructed in Rajasthan in a desert area with lot of sun radiation, but least like say water availability, but it could generate lot of employment for local youth. So, socio-economic impacts, you can see more than 12,000 plus total job roles were created. Most of them came during the construction phase, and very few are there, like 1,000 to 2,000 people are there for operation and maintenance and running of the plant. Land rights, the loss of grazing land. Because of the not all the impacts on socio-economy were positive. Some of the impacts were negative because of the huge area occupied by this solar PV plant. The traditional nomadic herding, it declined because the common lands which were earlier available for animals like camels to move around, that were fenced to protect animals as well as to protect the panels. Infrastructure, new roads and telecom were there, so it connected remote villages and improved the connectivity. Education, the aspiration for STEM, that is science and technology, local youth started moving towards technical vocational training for solar O&M jobs. Health and water, lots of CSR funded projects started implementing RO based plants to improve the access to clean drinking water in a critical water zone. Then economy, the land value or the price of land around the areas, because of the prospects of having new solar PV plants, the land values spike. So real estate boom happened in the entire Falodi Bhadla belt because of the industrial demand. And so far as recognition and impact is concerned, the tariffs are as low as 2.4 to 2.6 per unit electricity, and this was the groundbreaking low cost which set one of the global benchmarks. And so far as climate impact is concerned, it reduced 5.6 million tons of CO2 annually and powered 4.5 million homes by the energy generated through solar PV plant. So that was all for today's lecture as a final part of the solar PV technology. So what we covered today was discussed about National Solar Mission and some of the key schemes happened under this mission and how it was implemented in 3 phases from 2010 to 2022, later 2025 when the targets were revised. Then solar PV cost and subsidies, it is mainly provided at the central level to grid connected systems, but then there were some exceptions for off-grid subsidies, mainly for agricultural pumps, solar pumps, or in the remote areas, hilly regions where there is no grid. Then we looked at the major solar PV companies and plants in India whose capacity ranged from 9 gigawatt to 1 gigawatt, and then all those companies, most of them having module manufacturing capacity. Okay, in India it has reached up to 100 gigawatt, but cell capacity is still very low because we are relying on the import of material, mainly silicon, that is required for construction of PV cell. Then we looked at solar PV environmental impact, where we saw for PV most of the impacts are happening during upstream stages, whereas for fossil based or coal based power plant it is mainly during the operational phases. Upstream and downstream the impact is relatively low. And then finally we saw a case study of Bhadla solar park, which has like 2.2 gigawatt solar PV power plant in Rajasthan, and there were different how it was completed in 4 phases. Multiple funders and developers were involved in different phases of the project, and how it generated power for millions of houses and contributed to environment as well as created lots of employment. But then there were some environmental issues because of water scarcity, because of sand, because of reduced grazing land for animals. But then overall still it contributed positively to the socio-economic status of the region. And with that, let's close the lecture today. Thank you.